This recording is how to make a pictorial representation for an ionic compound. Pictorial representations allow us to visually see the ratio of cations to anions inside of an ionic crystal. I need you to remember that when we're making an ionic bond, it's nothing more than an attraction between a positive piece and a negative piece, or the cation and the anion. We're going to assign them shapes. The cation, you simply select a shape. So I say I select star. For the anion, let's say I select the shape, I don't know, something fun, smiley face. And then all you're going to do is draw those shapes in the ratio that they appear inside of your chemical formula. So the first thing you have to do is correctly write a chemical formula. So if we look at our crystal that's over here on the right-hand side, you'll notice an artist has given us a very pretty visual for vanadium 2 oxide. We can't draw these very well, so we're going to do our two-dimensional drawings in class. So first, the chemical formula. Vanadium 2 oxide. At this point, you should understand that vanadium 2 means vanadium 2 plus. Oxide, of course, is O2 minus. We employ our crisscross method. You believe the chemical formula is V2O2. However, you'll notice that does reduce down to VO. Well, now we have to assign shapes to the ions. The two ions are oxide and vanadium. So if we assign vanadium to be box, for example, and we assign oxide to be triangle, for example. These are my two shapes I'm going to assign. What's going on? There we go. Shapes to assign. I'm now going to bring those shapes down to this area and draw for myself my pictorial representation. According to the chemical formula that we just wrote, there should be a ratio of 1 vanadium to 1 oxide. So I'm going to draw one box followed by one triangle, and I continue that pattern. We normally continue the pattern for 4 or 5 times so that we can kind of see the repeating pattern. This is our representation of vanadium 2 oxide. This is what an artist does. Both pictures have the same ratio of 1 to 1, and you can see now why we reduce. Okay? If we look quickly at our second example here, we say, okay, we have calcium fluoride. Well, calcium is Ca2+. That's a plus. Fluoride is F-. We once again have to assign ourselves shapes. And so we say, okay, let's go ahead and we'll assign calcium to be star. And we're going to assign fluoride to be, I don't know, let's do heart. That's always a good one. All right. Now I must finish the chemical formula. So the chemical formula is CaF2. Looking at that, I realize I have to have 2 of the hearts and I have to have 1 of the calciums based on the chemical formula. Now, if you're asking how I know that, you have to look at the chemical formula and realize there's a subscript 1 for the calcium and there's a 2 here for the fluoride. That's where the 1 and the 2 come from in the ratio. So when I now go to draw my pictorial representation, all I'm going to do now is say, okay, I need 1 star and I need 2 hearts. Oh, those are the small hearts. Should have done it bigger. Here we go. And 2 hearts. This is my crystal lattice. Simply drawn here like this. And once again, we repeat this several times, which allows us to get a glimpse into what it might look like. Now, the artist rendition over here, you can see instead of shapes, they use colored balls. The colored balls are selected by the scientific community. We agree upon them. In this structure, though, however, you'll notice it doesn't look like the one on the upper right. In this structure right here, there are a whole bunch of crazy things going on that we'll get to later. Okay? So, a group of quick examples. First thing you have to do is write chemical formulas. At this point, I hope we're quick at this. You'll notice, you'll notice the first thing I did here is I chose magnesium chloride, which looks like this, and then I chose magnesium chlorate, which looks like this. Now, the reason for doing this is when we're solving these problems, people also get concerned about how do I decide what shape to assign. Well, you'll notice, first of all, it's 1 magnesium to 2 chlorides. It's 1 magnesium to 2 chlorates. Now, chlorate is ClO4-. Yes, that is a group of 5 atoms. However, we're going to assign it 1 shape. So I'm just going to assign chlorate to be circle. Okay? And over here, I'm just going to assign chloride to be circle. And, make this look like an arrow so it looks better. So, and then what I'm going to do over here is magnesium, because it's the same on both sides. I'm going to keep magnesium as star for both crystal lattices. So I've assigned a shape. So magnesium chloride, I need to have 1 magnesium, 2 chloride. So I go magnesium and I go chloride, chloride. And I go magnesium and I go chloride, chloride. And once again, we draw, 5-ish of these so we can kind of see a pattern. And this is the pictorial representation for magnesium chloride. Okay? Over here, I have magnesium chlorate. Magnesium chlorate also has a 1:2 ratio, and you'll notice if I draw this one, I draw 1 magnesium and I draw 2 chlorates. Now, as you're watching this appear, you may notice that the 2 pictures are identical. And the reason they're identical is because the ratio of ions in the crystal lattice is the same. Because they're the same, the crystal structures as we draw them look very similar. Now, when we get to solutions, you'll understand why we have to count ions this way. Now, the bottom 2 examples are going to look different because they are unique. Here we go. Nickel 3 sulfate. Here I have nickel 3 sulfate. Here we go, like this. Nickel 3 sulfate, you'll notice I'm going to need 2 of the nickels. I'm going to need 3 of the sulfates. I must assign them shapes again. I haven't used box in a while, so I'll use box. Okay, and on this side over here, let's keep ourselves as quick as we can, and let's use star, because star and box look different. Okay, so I need 2 nickels, so I go nickel, and I go nickel, and then I need 3 boxes, so I go like this. So this is what the crystal lattice would look like for a nickel 3 sulfate. Notice it's a ratio of 2 to 3, which is easy to see if you look at the picture. Okay? And our very last one over here is going to be a lithium phosphate. Lithium phosphate is Li3PO4. Okay, so I need 3 lithiums. I need 1 phosphate. I assign them shapes again. Let's do, for this one to make it fun, let's make it smiley face. That's not a very good smiley face. And for the 3, let's go ahead and make these triangles. So lithium 3 phosphate, 3 lithiums. So I need 1, 2, 3 lithiums. And then I need 1 smiley face. Make it smile. There we go. Then I need 3 lithiums. Then I need 1 smiley face. And once again, I repeat the pattern, 4 to 5 times so that folks can see the pattern. Okay? That ends this video on producing pictorial representations.